My name is Alexander Knopp, and this is Introduction to Combinatorics. In this video, we are going to study how to prove that something exists, and we are going to use the Pigeonhole Principle. Let's imagine that we have two cages, three rabbits, and we want to put these rabbits into these cages. So it's easy to see that we cannot put one rabbit per one cage, because otherwise we have at least one additional rabbit we need to put somewhere. So let's try to formalize this theorem. So the Pigeonhole Theorem says that if you have a function from n plus 1 to n, in other words, you have n plus 1 rabbits and n cages, then there are I and j, numbers from 1 to n plus 1, such that f of I is equal to f of j. In other words, the rabbit I sits in the same cage as the rabbit j. So in other words, this theorem said that if you have a bowl of alphabet soup and there are 27 letters there, then at least 2 of them are the same letter. Let's illustrate the theorem by the following example. Let's imagine we have a group of n people, and I claim that there are at least 2 out of these n people, such that they know exactly the same number of people from this group. How can we prove this? Let's define f from n minus 1 to n minus 1. We enumerate all the people from 0 to n minus 1, such that f of I is equal to number of people known to the ith person. Okay. Unfortunately, n minus 1 is equal to n minus 1, and we cannot use the theorem directly. What should we do? So let's consider two cases. If there is I such that f of I is equal to 0. In other words, there is a person who knows nobody. Note that it's impossible that there is another person who knows everybody, because in this case they don't know each other at the same time. F of j is less or equal than n minus 2 for all j. Hence, f is a function from n minus 1 to n minus 2, because all the numbers are less or equal than n minus 2. And it means that there are 2 people from this group who knows the same number of people. So there are I and j such that f of I is equal to f of j. Okay? And the second case is if there is I such that f of I is equal to n minus 1. So there is a person who knows everybody. In this case, f of j is strictly greater than 0 for all j. Because if some j knows nobody, it means that it doesn't know I, which is kind of a contradiction, because it should be n minus 1. So hence, f is a function from n minus 1 to the numbers from 1 to n minus 1. And note that this set has n minus 2 elements. So by this theorem, there are I and j such that f of I is equal to f of j. And it means that the ith person knows exactly the same number of people as the jth person. And it finishes the proof of the statement. Let's consider another imaginary case. So now we have 5 rabbits and 2 cages. So what we can guarantee about this case? So I claim that this time we cannot avoid the situation when we have 3 rabbits in one cage. Because let's imagine that we have 2 rabbits in each cage, and we have 1 additional rabbit. We need to put it somewhere, and it means that we have to put it with another 2 rabbits, so we'll have 3 rabbits in this cage. So now we may try to formulate this. So theorem. It's called the Generalized Pigeonhole Principle. So let's imagine that you have a function from n to k, and as in the previous case, n is greater than k. So then there are I1 to IL such that f of I1 is equal to f of I2 equal to f of IL, and L is greater or equal than the ceiling of n over k. One may illustrate this theorem by the following example. So if in the classroom there are 25 people, then 25 over 12 is 3. I mean, if you round it up. And it means that there are at least 3 people who were born on the same month. In this video, we proved the existence of objects of a certain type using the pigeonhole principle. In the next video, we are going to discuss permutations. If you have any questions, ask them in the comments. See you later.